Welcome to One Question at a Time, the SAT series. Question number 74. Let f of x equal negative x squared plus 2x plus 3 if g of x equal f of negative x. Then a point on the graph of g of x is. Before we start these questions, we look through the answer choices and we see that we have of the x value of the answer choice is -1, so the only difference is the y value, and that is x, and then they're asking for they're asking for if when x equal -1, what is g of -1. When we see that, right, we have a few point of view, like 3 ways to solve for this problem. The first one, we don't care about anything, just plug in, right? So we can do, to find g of x, we do f of negative x, and we plug in by negative, open parenthesis, x squared, right, minus x squared plus 2x plus 3. And remember, right now, whenever we see x, we plug in negative x. Okay, then we will find this one is minus something negative square will be just that absolute value or positive part of it square, right? We minus 2x plus 3. So let's talking about the negative x squared. This one is the same thing as we have -1 multiply x squared. Then when we distribute the power in, we will have -1 squared multiplied by x squared. That is -1 squared is 1 multiplied by x squared, that is x squared. Okay. In this question, we also have the minus in the front of the minus x all square, so the negative still out there. Okay, where it's still out there is still at the final answer, right? Now our job is just finding what is g of -1. Then we have minus of -1 all square minus 2 minus 1 plus 3. So be careful for the side, right? So -1 square is negative 1 square is 1, but we have the negative in the front. Then we have -2 times -1, that +2 at 3. So this is -1 at 2 at 3. That is 4. -1 at 2 is 1 plus 3 is 4. Okay, so we have B is the right answer. But how about if we not go straight forward like that, what can we do? Okay, so we have g of x is f of -x. Now if we have g of -1, right, then that will be equal f of, remember the negative in front, then x now is -1. Now this one is become f of 1. So this is the second method when we just plug in f of 1 to find f of 1, that is g of -1. So g of -1 equal f of 1, see that? And that equal to minus x squared, right? We plug in the f functions. So x squared minus x squared is 1 squared. Add 2 times 1, add 3. And we have 1 squared is 1, but we have the negative in the front, so we will have equal -1. We add 2 times 1 is 2, add 3, that also gives you 4. Okay, so the third method is we have to memorize the transformations. So see, g of x is equal f of negative x. So it's reflections over the y-axis. So you see that right here we have the negative x on the side right here, right? That's the transformations. This is the g of x. This is the f of x. After the f of x transform by to the negative in front of x right there, you will have the g of x, right? So the g of x in this case we will have like minus x comma y. And you see that we're already saying we have the -1 in the front, right? So that negative right here, right? And then x equal 1, that's how we compare x equal 1. G of x is like that. It means g of -1. Now we just try to find the y value, right? So how can we do that? We see the negative in the front. This one, let's say g of -1, to making sure we're not confusing, right? It's the same thing, but when you see that, you will figure out that we have negative here, we have negative here, we have negative here, so x equal 1. So on this side, x will be equal 1, comma y. And that's y, and this y is the same thing, and this y is what we try to find. So in this side, we say this is the f of x, right? So that's why we have this y equal f of x. And we figure that out is f of 1. This is f of 1. And f of 1 is the same thing at g of -1. You see how we use that fact right here, and then we find out right here. That is common sense when we just kind of don't remember what the transformations look like. But if we do know the formulas, that make it easier, right? So now we just find out what is f of 1. We plug in, then we have the same answer at 2, right? Thank you for participating in this series, and see you next time.